Today, we are pulling back the curtain on a technology that powers some of the smartest apps you use every single day: graph databases. We're going to find out how simple connections, the little lines between data points, can create some seriously powerful intelligence.
So let's just start with this. Picture it. You finish your great movie, the credits roll, and boom, a recommendation pops up that feels, well, perfect. It's exactly what you were in the mood for. How on earth does it do that? I mean, is it some kind of magic? Or is there something else going on, just under the surface?
Well, here's the big reveal. The secret isn't just about knowing that you watched a movie. It's about understanding the connections between everything. The relationship between you, that movie, its director, its actors, and crucially, what other people who liked that same movie also liked. It is all about the relationships. And to really understand those connections, we kind of have to change the way we look at our data. We need to start, thinking in graphs. And that brings us to the world of graph databases. This is the whole idea right here. See, unlike other systems that might bury those important connections deep inside endless tables, a graph database puts them front and center. They're the star of the show. In this world, the relationships are just as important, and sometimes even more important, than the data points themselves.
So how does this all work? Well, the most common way is something called the property graph model, and what's amazing is how simple it is. You've really only got three main parts. First, you have nodes. Think of these as your things or entities. Then you have relationships, which are just the named connections between those things. And finally, you have properties, which are just little details on either the nodes or the relationships. That's it. That's the whole shebang.
And if you want a really simple way to think about it, just think back to grammar school. It's honestly that easy. Nodes are your nouns, the people, the places, the things, and the relationships, they're the verbs, the actions that connect everything together. A person acted in a movie. A customer bought a product. It's just so intuitive.
Okay, so to really get why this is such a game changer, let's put it side by side with the old way of doing things, the world of traditional databases. In a traditional database, all your information is locked away in these rigid, separate tables. So you might have one big table for all of your users and a completely different one for all your movies. They basically live in their own little silos, totally unaware of each other.
So how do you figure out which user watched which movie? You have to perform this painful operation called a join. You're essentially telling the database, hey, go smash these two giant tables together and try to find all the rows that match up. Now, with two tables, it's okay. But what happens when you want to connect users to movies, to actors, to directors? These joins get incredibly complex and, more importantly, incredibly slow.
Now, let's contrast that with a graph. Think about it. When you're brainstorming an idea, what do? You grab a whiteboard, you draw some circles, and you connect them with lines, right? Well, a graph database is designed to look exactly like that drawing. You don't have to force your real-world idea into a bunch of awkward tables. It's just natural.
And here's the technical magic that makes it all so fast. It's a concept called index-free adjacency. All that really means is that every single node has a direct physical pointer to the nodes it's connected to. It's like having a direct address. So hopping from a person to a movie they acted in is just one quick jump. And here's the crazy part. It doesn't matter if you have 1,000 movies or 1 billion movies in your database. That jump always takes the same amount of time. This is what makes graph databases unbelievably fast for this kind of connected data.
Okay, so we've got an intuitive model, and it's super fast. But how do you actually talk to it? How do you ask it questions? Well, for that, you need a language that's built for graphs, and that language is called Cypher.
So, Cypher is a query language designed from the ground up for graphs. If you've ever used SQL, it might feel a little familiar, but it's built on a totally different idea: pattern matching. Instead of telling the database step by step how to find your data, you just describe the pattern of the data you're looking for.
And just look at this. This is what a Cypher query actually looks like. It's almost like ASCII art, isn't it? The parentheses represent the nodes, so you've got a circle for a person and another for a movie. And the square brackets in the middle, that's the relationship, the acted-in part. You are literally drawing the pattern you want the database to go and find for you.
And that's the real beauty of Cypher. It ties right back to that whiteboard idea we talked about. You're not really writing complicated code. You're just drawing a little picture of the answer you're looking for, and the database does all the heavy lifting to find it.
All right, let's tie all of this together. We've got an intuitive model, a lightning-fast engine, and a super simple query language. So what? Why does any of this matter in the real world?
Well, it matters because it unlocks insights in some really powerful ways. We started this whole thing talking about real-time recommendations, but that's just the beginning. It's used for fraud detection, instantly spotting complex fraud rings where, say, a bunch of fake accounts all share the same credit card. It's used for something called master data management, which is just a fancy way of saying you can finally get a single 360-degree view of your organization. And of course, it's the absolute perfect fit for social networks. All of these are problems about connections.
So the whole graph advantage really boils down to three big things. First, the data modeling is just so intuitive. It's whiteboard friendly. Second, the speed for finding paths and hunting down connections is completely unmatched by other systems. And third, it's incredibly agile. If you want to add a new type of relationship tomorrow, you just add it. You don't have to rebuild your entire system from scratch.
And that really brings us to the single most important idea to take away from all this. In the hyper-connected world we live in, the individual data points are becoming less interesting. The really valuable insights, the game-changing discoveries, live in that web of relationships between everything.
So I'll just leave you with this final thought. Now that you know how it works, now that you can see data as a network of connections, what hidden patterns are just waiting to be discovered in your work or your industry or even your own life? What connections out there could change everything?